Welcome to Lesson 9, applying the properties of operations to add and subtract rational numbers. Okay, before we get into the quote-unquote classwork part, what we should do is have you do a couple of sprints. So let's find those pages. Okay, well, I'm going to try to go ahead and administer this sprint with you right here. I just need to, of course, count on your absolute honesty. So if you would go ahead and turn to your integer subtraction sprint, that's in the back of your lesson 9 there in your binder, and get ready. And what I will do right here on this recording, I will go ahead and say start. And hit my start button here on my my stopwatch, and we'll say stop when I want you to stop. Okay. Now I don't think I explained this well enough in the first batch of sprints, which was in lesson 8, but you are to do them in succession. So there's should be no skipping around, okay? So you're going to go do 1, you're going to do 2, do 3, do 4. You want to just work that way, okay? And that way. No skipping around, because, of course, some are going to be easier than others, and we just want you to become more fluent and be able to take on an integer addition or subtraction problem and be able to do it fluently, okay? So if you would just go ahead and do this, I'm going to pause this. Well, actually, I won't pause it, but you can go ahead and pause the recording just to get yourself ready. And when you are ready, come on back, turn it on again, and I will lead you in this sprint. Okay, so hopefully you're back. You're all ready, ready to go. Got your pencil. I hope you haven't studied too much these questions here, but. Anyway, the more honest you can be with this process, the better, of course. Okay, so I'm going to say on your mark, get set, go, and you can start. So here we go. On your mark, get set, go.
Fix.
10 seconds left. 5 seconds. And stop. Okay, so now that you've stopped, go ahead and just add up your, just go ahead and check it. You know where the answers are. The answers are in the binder answer section at the website. If you want to just pause right now after I stop talking and check your answers. Come on back, and we'll do round 2. Okay, and again, remember to write your correct answers over here. Okay, so go ahead and correct your sprint and come on back for round 2. Okay, well, I hope you fared well on round 1 and do even better here on round 2. So again, hopefully you have your round 2 sheet in front of you, and you can see, here we go, we're looking at that round 2 sheet right here. Okay, I'm going to go ahead and do the same thing. Say on your mark, get set, go, and then you guys can get started, and I'll stop you in 1 minute and just warn you about 50 seconds in, and then with 5 seconds left, and just like I did last time. Okay, so hopefully you're ready. If you're not ready, you should pause right now and get ready and come on back. All right, so here we go. On your mark, get set, go. Ten seconds left. 5 seconds. And stop. Okay, so again, go ahead and go to the binder answer section, find the answer to this round 2 sprint, and write your number correct here. Compare that number to round 1, and then your improvement number here. Okay, and let's hope we have some improvement there. If we don't, that's fine. Again, this all takes practice to become fluent, and what it means to be fluent is to do things pretty much quickly, being able to look and just know immediately what an answer is, okay? Alrighty, so I hope that went well, and let's go ahead and start our lesson in earnest. Okay, so in the classroom, this exercise 1 right here would be, I would have cards like these right here. These would all be individual cards that were cut up, and you could work to move them around. And what you're trying to do is you're trying to unscramble those cards and show the steps in the correct order to arrive at the solution to this problem right here. Okay. As you can see, well, as you know, we're not going to cut anything out. I'm not going to give you cards. It's a great activity for the classroom, and I will actually do this with you the next Monday. You come in after this lesson 9, and we'll do this scramble thing. I think it's quite a be quite a fun activity. I think we can do together in pairs or groups or as a class. But anyway, what you're going to do here, I just figure in your binder, just go ahead and put numbers. So we have 1, 2, 3, 4, 5 different steps. Okay, so here's where you're starting from. You're starting from here. Okay, and then you're going to go ahead and just label them 1, 2, 3, 4, 5. Right next to them. So if this is, well, let's just, we have a good idea of what the last step is, of course, and that's this one here, which is the answer, right? Okay, so that's 5. So go ahead and then label each of those 1, 2, 3, and 4, those that are left, and come on back and we'll do it together. Okay, and while this maybe initially looked pretty simple, I mean, it is kind of confusing because you look at all of these, they look rather similar, okay? But the first thing I would have said that would have been done would have been this one right here. This would have been step 1, okay? And so with this one here, what it seems they have done, again, they've changed everything into sums, okay? So this whole idea of the opposite of a sum is the sum of its opposites, okay? You can see where this right here said 5 2/9 minus, and this minus then applies to everything that's in the parentheses, okay? So what they've done here in this step 1 is they've said, so this is 5 2/9 plus, okay, a negative 8.1 plus a negative 5 2/9. So what they've done is they've actually shown that, because this is real confusing here. When you look at, I should probably get this out of the way so you can actually see it, but when you look at this problem initially, and this causes a great deal of confusion to kids, you look at it and you say, okay, so it's 5 2/9 minus, and then our tendency is to just subtract out that 8.1, but then add that 5 2/9, okay, which is not the case, which is not true, okay, because what this the negative symbol, or that negative symbol in front of the whole entire parentheses, means that both of these expressions, 8.1 and 5 2/9, are both negative. Again, that negative sign that sits in front of these parentheses means that everything in that parentheses is negative, okay, is negative. And because this is here is a positive, that means that that 5 2/9 is also going to be negative, okay? So you can see what they've done down here is they've kind of separated that out and shown that using parentheses around 5 2/9, for example, negative 5 2/9, to keep that all together, okay? Now I would have said that would have been number 1, and pretty darn sure that that is the first step. Okay, so the next step would have been this one here, okay? And it's a step, but later on we'll probably see that maybe it's one that we could actually maybe skip, because we could have gone right to this one, which would have been step 3. But let's talk about step 2 first. So what they've done is they've reordered. You can see they've reordered things here, where they've actually put they've moved negative 5 2/9, that's in the parentheses, to the front, and put the negative 8.1 behind it, just so you can actually see these two together. Okay, so they've used that commutative property, moving the order around with addition. Okay, and again, we are talking about addition. Okay, this applies to addition, commutative property, to both addition and multiplication, not to subtraction nor division. Okay, because they're very different. Okay, so they've kind of reordered things in number 2. In number 3, what they've done is, because we have sums of these different rational numbers, we can then reorder again, in this idea of this associative property here, which is very similar to commutative. But now what they've done is they've taken all of this and put it in parentheses, okay, because again, we are not changing anything, okay, because we're just changing the way it looks and how it and how easy it makes it for us. We still have 5 2/9 here. We have 5 2/9 there. Okay, we're still adding. Okay, we're still adding that, and now we have we're adding its opposite to itself. Okay, which is negative 5 2/9, which was actually sitting right here before. Okay, and then we are going to go ahead and then subtract away, or actually add, of course, add this negative 8.1 here. Okay, we're going to add that as well. So what happens is that, of course, this is the next step. These right here, because they are opposites, they are going to cancel, okay, and they become 0, as you see right there. And then our negative 8.1 is going to sit by itself right here. Okay, and again, that's an addition. We're summing still. And then we're left with, of course, 0 plus anything is that anything, and we have our answer, 8.1. Okay? So again, I know this takes a lot of, excuse me, this takes a lot of practice, and it's not that easy to begin with. So we will look at this again and again. Okay, so in examples 1 through 2, this example 1 we're going to do together, and again, steps can always vary, and the truth is, you can look at this problem right now, and I can see the answer. You are probably noticing something as well, but this problem does present another tricky area, an area where children often have some issues with. Okay, and that's this idea of this negative sign here, and then a negative sign within the parentheses. Okay, because a negative sign is also also means do the opposite of. Okay, you could look at this negative sign here in front of the parentheses as just telling you to do the opposite of what is in that parentheses. Okay, so I'm just going to talk through this just a little bit, It's not going to be part of the steps, but just something that I'd like you to consider for the future. Because right now, right here is, oops, I don't want that. Right here we see that this 4 and 4/7 within the parentheses is actually a positive number, but this negative sign, okay, in the front of that parentheses is going to make that become negative. And while that 10 is negative inside of the parentheses, that negative sign is then going to allow it to become positive. It's truly going to be a positive 10 because you're doing the opposite of what is designated inside of that parentheses. Okay, so let me clean up that mess, and let's just go through this in some steps that are recommended here. Okay, so this first step is going to just kind of not rearrange things, but just change some signage because of the fact that subtracting a number is the same as adding its inverse, if you do remember that one. And so what that would be, it would look like this. So we would have 4 and 4/7. Okay, some difficulty with this pen. 4 and 4/7. Okay, and we're subtracting. And now we're going to change up what is inside of that parenthesis. We're going to deal with this parentheses first. So it's going to be 4 and 4/7. So instead of looking at this as a subtraction problem inside there, we're going to go ahead and add. Okay, add a negative 10. Okay, so we're just going to look at that way, and you can see how we have parentheses inside parentheses, and you saw that in the problem before. But yeah, so now we have 4 and 4/7. Take away, and of course we're going to change that soon enough. And then inside the parentheses, 4 and 4/7 plus a negative 10. And again, subtracting a number is the same as adding its opposite, okay, or adding its inverse. Same thing. Okay, and you don't need to memorize all of this, but you need to know what I want you to know, or just come out of this lesson knowing, is that there are reasons, there are properties of these operations that allow you to do these different things. Okay, I couldn't do this if I didn't have a real true reason for doing it, and this is the basis for me doing that first step. Okay, so now second step, which you become familiar with, I hope, and that's this idea of the opposite of a sum is the sum of its opposites, and you can imagine what we're about to do here. We're about to do this, so we have 4 and 4/7, and we want to make this a sum now. So we're going to add, okay, and what we do is inside of this, we are going to actually, the sum of its opposites, so the opposite of 4 and 4/7 is negative 4 and 4/7, okay, and the opposite of negative 10 is 10, okay. So that makes things really clear, and you can just look at that step and what that has done for us, okay. It's made things incredibly clear. Now, I would have said, honestly, I could have started right here, okay. I could have started right here and totally avoided this first step, because I know that negative sign, what I had told you before, just changes everything up inside of a parentheses, just turns everything opposite of what it is in that parentheses. But we want to talk about properties and talk about the reason why we do things. So this one, of course, the justification for this second step here is that the opposite of a sum, remember this one, opposite of a sum is the sum of its opposites. Okay? And that's our rationale, our justification, our reason for that step right there. Okay? All right, so the next step, what we want to do is let's use associative. And if you remember associative from over here, that was the step number 3. And what associative tells us we can do is we can change where things are located. and we did that right here. If you remember, we put these two in the same parentheses, taking the 1 out of the parentheses in step 2. Okay, so that idea of the associative, what we'll do here then, you can imagine what we'll do here is we're going to put these 4 and 4/7 together. Okay, so we're going to have 4 and 4/7 is all going to be in parentheses, and we're going to add a negative 4 and 4/7. You imagine what that's going to be already. Okay, 4 and 4/7, and then we're just going to add that 10. Okay, and again, that was using the associative property. Again, this is not about you memorizing necessarily these properties, but just knowing that each step along the way is justified because of these properties. Okay, and now of course we say a number plus its opposite equals 0, and that's what this relates to. And of course then we have plus 10, and that is going to equal 10. Okay, all right. Again, you could have looked at this from the beginning as I did, and I could see the answer was going to be 10, but knowing all of these steps, following these steps one by one, again, is what we're trying to practice, and that's all part of it. The truth is, our goal here, of course our goal is to get the correct answer, but more so our goal is to follow steps, okay, because that is a big part of the whole algebraic process. Okay, it may look easy at the outset, finding an answer easy at the outset, but honestly that is not what it's about. Okay, this is what it's about, showing and being able to explain your steps. Okay, now a good habit to get into, here we are with this number 2 here. A good thing to do maybe immediately is to just make a prediction as to what the answer is going to be. Okay, and I look at this here, and I'm looking at 2 separate parts. Again, I know this is a sum. This is already a sum. It's very conveniently a sum already. So I know I have 5 as a positive, and I know I have a negative 4 and 4/7. So I know my answer. I know my answer already. But predicting wise, it's going to be about between, well, I don't know, between 0 and a half, whatever. Okay, we could say between 0 and 1/2. Maybe for you who aren't as sophisticated as I am with this. I don't mean I'm sophisticated. It's really not. But in terms of my knowledge of these processes, okay, I'm predicting, okay, what the answer will be. Anyway, let's just go ahead. We can look at this. We could take this apart, start stepping through this problem. We can look at maybe a first step is maybe we can since we do have a whole number here, just a whole integer, and then we have a rational number here, a fractional, actually a mixed number. Let's go ahead and let's mess with that mixed number here. So we know that a mixed number is nothing more than a sum of its parts. Okay, is actually the sum of two parts or 2 rational numbers, and it's actually equivalent to negative 4 plus a negative 4/7. Okay, so we have actually been able to take that apart. Okay, take that apart there. All right, and then we can do associative property. So what we can do is we can go ahead and take these whole numbers. Okay, this 5 plus this negative 4. Okay, taking those out and put those together, and then we could go ahead and add that negative 4/7. Okay, and I hope this idea of adding a negative is becoming more and more comfortable for you. Very, very helpful in doing algebra. So now we can just take what's inside of the parentheses here, and we know that a positive 5 and a negative 4 is going to leave us with a positive 1. And then we still have this negative 4/7 looming. Okay? And, if we want to, we can go ahead and just if we need to. We can just change this 1 to 7 over 7. Very convenient to have a whole number because that's all you have to do. And then we add a negative 4/7 to that. And then we know that equals a positive 3/7. Okay, and yeah, that's our answer. Okay, this next exercise, exercise 2, is called teamwork, as you can see there. Really a lot of fun in class, and it's something that I will hopefully have you guys doing when you do come to class on the Monday following this lesson. The idea is you would get into teams of 3, and each one would have a different color pencil, and you would write down the different steps of the process. Okay, and of course, have to have at least 3 steps so as to give everyone a chance to participate, to actually write in line. Okay. Well, of course, we're not doing that in class right now. Let's just go ahead and practice this process together. What I'm going to do is I'm going to go ahead and make do the first step for A, okay, and then what I want you to do is go ahead and pause, and then you come up with a second step, okay. Alrighty. So what I want to do here is I want to get rid of this minus thing right here. Okay, I'm going to take that off. So I'm going to go negative 5.2. Then I'm going to add, okay, because remember subtracting is the same as adding an opposite, okay? So that means I can add the opposite of negative 3.1, which is positive 3.1. It's not a comma, it's a period. 3.1 plus, continuing there, plus 5.2, okay? All right, so that's what I have right there. That's my little messy step. If you would go ahead and pause and just see what you might want to do. Might want to rearrange or whatever. Again, we need to do this in at least 3 steps. So, all right. So go ahead and yeah, take a shot at the next step. Okay. Well, while I'm not sure exactly what you guys did, I went ahead and just moved things around using my commutative property, commuting numbers. Okay, and I just took that. I wanted to put this negative 5.2 and 5.2 right next to each other. Okay, again, I mean not entirely necessary, but in terms of steps in the process, it is indeed necessary. If you are asked to do it, that's what you need to do. Okay, so it makes sense then. The sum of opposites is 0. Okay, right there would be a next step, plus 3.1. All right, and then of course 0 plus 3.1 is 3.1. So that would be the answer. And again, many of you could get the answer from up here, but working this problem out is not merely giving the answer, but actually showing a step flow. Okay, so go ahead right now. What I'd like you to do is just go ahead and finish the next 3, B, C, and D with, and again, you have to be at least 3 steps. So at least 3 steps. Okay, and yeah, go ahead and finish those. And again, while if they make sense, if your process makes sense, then that's right. Okay, it just has to make sense. Again, it's not about just getting that correct answer. It's about showing your work and showing those steps. Okay, so when you come back, you'll see mine all complete, and you can pause and you can look it over. I won't go over it step by step because I want to make this hopefully make this lesson a little bit shorter. Okay. Okay, I'm going to show you these. Show you B and C right here, but I've taken a lot of room with them, so I won't do D until you pause and take a look and yeah, and see what I've done. Okay, you can see in B, took that negative 12 and 7/8 and turned it into a sum of two rational numbers, and recombined moving things around, commuting numbers to then put the two integers together and left the fraction apart, and combine those integers and then added them up at the end. And again, this idea here of knowing what 20 plus a negative 7a is, this is important for you to know. And it's not something I'm going to continue to teach. This is something, again, in the summertime. This is why I had assigned all of that fractions work to you. Okay, my goal here, the primary goal, is for you to know different steps in the process. And again, it's not about getting an answer, looking at this here and getting an answer. It's more about following logical steps using the properties of these operations. Okay, so go ahead and take a look at C, and you can pause right now and see what I've done. Maybe make some changes to your process. You pause right now and come back, and we can check D. Okay, so here we are back and looking at D. As you can see, my first step was this one right here, is to take care of this minus a minus thing. Again, any subtracting, in this sense of subtracting a rational number, is like adding its opposite. Okay, and therefore I was able to add the opposite of negative 8, negative 1.8, which is 1.8, positive 1.8, and then well, what I did a couple of things at the same time. And then at the same time, I did this one too. I just added the whole adding the sum of its opposites idea. Okay, so I just added a negative 4.5. All right. From there, the second step in red here, I went ahead and just moved things around, used my commutative property to move my negative 4.5 closer to my 16/20ths. And then in the green step, you can see that I found a like fraction, a common denominator. I turned negative 4/5 over here into negative 16/20ths over there, which in the purple step, as you can see, just so happens that 16/20ths and negative 16/20ths, the sum of opposites is 0, and then just added this 1.8 and ended up with this answer 1.8. And again, it is less about the answer and more about the process. Okay, in this final exercise, exercise 3, what I want you to do is go ahead and explain step by step how to arrive at a single rational number to represent the following expression. Show both a written explanation and the related math work for each step. Okay, so what that means is this. All right, I'm going to give you first step. Okay, I'm going to go ahead and use this rule, and again, I always focus on this right here. Okay, I always focus whenever I see a subtracting, the subtraction in the parentheses. I want to get rid of that, and the way I get rid of that is by applying this idea. So subtracting, and I'm going to use the numbers actually from this problem, and I'd like you to as well. So subtracting negative 1/2 is the same, and again, I'm having a hard time keeping things small here. But on your sheet you'll be able to write smaller. I just can't with this pen. So it's the same as adding its inverse. And again, you remember what the inverse is. Its inverse, any number's inverse is just the opposite of it, and that is 1/2 would be the opposite of negative 1/2. Okay, so if I did do that, then my expression would look like this. At this point, it would be negative 24 plus 1/2, because that is the same. Subtracting the negative 1/2 is the same as adding its inverse, which is 1/2, plus, and again I'm changing this up too here at the same time, which is the same exact thing, plus negative 12.5. Okay, so here's my first, this would be my first step right here. What I've done is I've explained it, telling you the property that I'm using, and then writing the expression as it has evolved at that point. Okay, for you, what I want you to do then is to go ahead and do next. I use blah blah blah. Okay, and then next until you have gotten to the final answer. Okay, so go ahead and do that, and come on back and take a look at what I did. Okay, so here are my steps. We we had that first step here, subtracting. Again, I like to deal with that first. Subtracting negative 1/2 is the same as adding its inverse of positive 1/2. I went ahead and rewrote my my expression here, as you can see there in the brown. All right. Next, in the red, I used the commutative property, and that commutative property allows me to commute numbers, and that means to move numbers around to, now again, when we're talking about addition, okay, we're talking about addition, and that's why I change everything to, well, that's why this first step is very critical, is by changing everything into sums, okay, because if I am adding, I am allowed to use commutative property because subtraction does not allow it, okay. That's why we do this first step, which is makes a great deal of sense. Okay, so again, in the red, I used the commutative property, and I just moved that negative 12.5. I moved it over right next to my negative 24, again, to get those two things close to each other, and actually just separating out this fractional value over here. Okay, so in the green, I added those negative numbers. And I know if I'm going to add two negative numbers, I'm going to just continue right on the, continue left on that number line. I'm at negative 24, go another 12.5 to the left, and I end up at negative 36.5. And just have that down there, then I'm adding a half, plus the half stays there. Now, purple's really important part, and hopefully you guys can grasp this and do this well. Again, with 1/2, this does not take much effort, but there will be other fractions that will not be as easy to convert to decimals. Okay, so right here you can see in purple, next I wrote 1/2 as a decimal, okay, and that of course is 0.5, very easy, but there will come a time maybe you'll have numbers like 3/8 and you'll want to use a maybe a calculator to figure that one out, and that would be 3, of course 3 divided by 8 would give you a certain value. But anyway, yeah, just converting that, because you want them to look the same. I mean, you could have actually converted the negative 36.5 into negative 36.5 as a mixed number, but the decimal just seemed easier to me. So again, I ended up with this. And then finally, I just added those numbers. And again, remember, if I'm at negative 36.5 and I'm going to add a positive value, I'm going to move right on that number line, and that's going to take me to negative 36, which is about, which is this 0.5 to the right of negative 36.5. Okay, so in summary here, just want to just implore that you do use the properties of operations, okay, that we have looked at more deeply in this lesson than the others that preceded it. Those properties such as the commutative we use quite a bit. The sum, the opposite of a sum is the sum of its opposites. This idea that subtracting is same as adding the inverse of a number. Okay, all of those that create more increased efficiency. Okay, so these properties of operations to add and subtract rational numbers make us more efficient. Okay, and then they give you an example right there. Again, this opposite of a sum is the sum of its opposites. Very, very important concept to follow, and it is one that allows us again to be much more efficient. Okay, and That is that idea of taking a mixed number, for example, and splitting it apart into two rational numbers. More important than many concepts you'll see. Okay, so again, keep practicing these skills. Go back, take a look again, just to keep solidifying these properties of operations, and hopefully you'll come to realize that they will make you much more efficient. And again, one more time, and I've said this many times throughout this lesson, it is not about getting the correct answer necessarily, but following the steps. Because assessments in this curriculum are going to be geared towards you showing your steps and explaining your process more so than arriving at a correct answer. I don't want to diminish the importance of a correct answer, but those steps are of primary importance right now. Okay.